For our second lesson in 4.1, we're going to be looking at 4.1b, representing linear relationships using graphs. And our goal for this lesson is to learn to graph linear relationships from an equation using a table. So essentially what we're going to be doing is we're going to be making the tables just like what we did in 4.1a, except we're going to be taking that a step further, and we are going to then plot those points that we make with the table onto a graph. Then we have to determine whether or not to connect those points with a line or just leave the dots as is, and I'll talk more about that later on in the video. And so we need to start this lesson with a little bit of vocabulary. So really the only term that we want to go over this lesson is for what is called a linear equation. So our term is for linear equation, which is an equation whose solutions are ordered pairs that form a straight line when graphed on a coordinate plane. So if we think back to the tables that we were making in 4.1a, because those tables had a pattern with both the x values and the y values, when we see that, that's going to give us a linear equation. Now there are several different ways in which a linear equation can be written, but the most common form that we're going to be using throughout really for the next month or a couple months coming up is going to be y equals mx plus b, and we'll talk more about what each of those variables means later on as well. And it's important to note that when b does not equal 0, so when there's an actual value in place for b, the relationship is not proportional, meaning that the graph does not pass through the origin. And we talked about how when a graph of a line does not pass through the origin, that makes it non-proportional. Now I realize this is just a lot of words and terms and definitions and that kind of thing, and it might not make all that much sense right now, but as we get into some examples, hopefully you'll understand a little bit more clearly what's going on. But if it doesn't, make sure that you're writing down questions in the margin of your notes so that you can ask those during class. Alright, so let's look at a couple examples. You will have to use graph paper for these examples. So for our first example, we want to graph y equals 2x minus 1. Now if we compare this to the original form, where we have y equals mx plus b, we see that 2 takes the place of m, and minus 1 takes the place of plus b. We'll be talking much more about that in upcoming lessons, and we'll be using that to come up with a shortcut to where we won't have to do all this work that we're learning for this lesson. But for now, we need to make sure that we're able to actually go through, make the table, and then graph the line using the values from the table. So let's take a look at how we do that. So as a review from yesterday, we start off with our table, and we can use any values for x that we want. We're not giving any stipulations on what our values for x need to be. In the math curriculum itself, it might give you specific values for x that you need to use, but if there aren't any values given, then you can use whatever values you want. Now, we can, if we look at our value for m as 2 over 1, because our denominator is 1, we can go up by 1. If our denominator is something different than that, then we should go up by whatever value the denominator is. So I'm going to choose 0, and then negative 1, 1, and 2. Okay, so those are my 4 values for x that I'm going to use. And so just like yesterday, we need to fill out these values for y. So I'm going to do that work below the table. So I recopied my equation, y equals 2x minus 1. I'm going to take my 4 x values that I have here, and one at a time I'm going to substitute each of those x values in for x here. I'm going to get a value for y as my answer, and that value for y is going to go in the bottom row of my table. So to start off, let's use negative 1 for x, so we have y equals 2 times negative 1 minus 1. All I did was substitute negative 1 in for x. Now I show my work. 2 times negative 1 is going to give me negative 2. Bring down the minus 1. So y equals negative 2 minus 1 is going to give me negative 3. So when x equals negative 1, y is going to equal negative 3. Now I have to repeat that process using the other values for x as well. So my next value for x is going to be 0. So I substitute 0 in for x. Next line of work, I have y equals 2 times 0 is 0. Bring down the minus 1. So y equals 0 minus 1 is going to equal negative 1. So when x equals 0, y is going to equal negative 1. Next value for x I'm going to use is going to be 1. So I substitute 1 in for x. I go ahead, simplify the right side. 2 times 1 is 2. Bring down the minus 1. So y is equal to 2 minus 1, or y equals 1. So when x equals 1, y also equals 1. My final value for x that I'm going to substitute in is going to be 2. So when I substitute 2 in for x, y equals 2 times 2 is 4. Bring down the minus 1. 4 minus 1 is going to give me y equals 3. So my final value for y will be 3. Notice I have a pattern in the top row with the x's. You'll see that I'm going up by 1 there. And for the y values, you'll see that there's a pattern there as well, where I'm going up by 2 each time. So if there's a pattern in one row, you should see a pattern in the other row as well. If you don't see a pattern in both rows, something is probably off. All this is what we did in 4.1a. This isn't anything new that we're going over now. But now what we need to do is we need to take this a step further, and we need to actually graph these points on a coordinate grid. And it is necessary and important that you're using graph paper for these. Okay? You need to make sure that you have graph paper, that you're using it. Otherwise your points will not be perfectly placed, and you need to make sure that they are. I will at some point start taking out points if the notes that you submit are not done on graph paper. You need to make sure that you have graph paper at this point. So now what we're going to do, we're going to go ahead and plot these 4 points. Our first point that we're going to plot is going to be based on this order pair here, which is negative 1, negative 3. So when I plot that point, my x value tells me to go left or right. So I go left 1 from the origin. My y value tells me to go up or down. So I go down 3. So left 1, down 3, puts me right about here. So my first point is going to go right there. Next order pair, 0, negative 1. I don't go left or right at all, but I do go down one value, one grid line. Next order pair is 1, 1. For that I go right 1 and then up 1 and place my point. And my final order pair is going to be 2, 3. For that I go right 2 and up 3. And I have my 4 points. Now when we look at those 4 points, clearly they form a straight line. If you get done plotting your points and they are not in a straight line, something is wrong. Either the math that you did to get the order points is wrong, or you plotted them incorrectly or something along those lines. Okay? Now once you have your points, you need to use a straight edge, your ID or a ruler or something like that to draw your lines. I unfortunately cannot draw straight lines, or I cannot use an ID or anything like that on my iPad because it just does not work. So bear with me, I'm going to draw the best line that I can, but you guys need to make sure that your lines are straight. So your final answer is going to look like this. Okay? The graph of that line, that is the answer. I'm all done with this problem. The graph y equals, or the equation y equals 2x minus 1 correlates to that table and that graph. They're both different ways of representing the same equation. So for our next equation, our next example, we have y equals 2/3 x plus 4. It's going to be a little bit more complicated, especially having that fraction in for our m value where our slope is. So y equals 2/3 x plus 4. Same process though. We create a table, and then from that table, we graph a line. So I'm going to set up the table first. Now to help me set up my table, I'm going to place a 0 here like I normally would. But now what I want to do is I want to look at the denominator of my fraction, which I have right here. The denominator of this fraction. That tells me how much I want to go up or down by for my x values. That will make the math much easier later on. So instead of going up like by 1s like I did for my first example, I'm going to go up by 3s this time. Okay? So I go up 0, 3, 6, and if I'm going to go in the other direction, I would have a negative 3. And this again will just make the math easier later on. So I'm going to copy down my equation below the table, and then we're going to start substituting in our x values to find our y values. Alright, so I recopied my equation. Y equals 2/3 x plus 4. I'm going to start substituting in my x values, starting with my first x value here, which is going to be negative 3. So I'm going to take this negative 3 and substitute in for the x there. Again, when I substitute in the value, when I substitute in that negative 3, the x goes away. I'm replacing the x with the value. So negative 3 goes in place of x. So substituted in my value for x, replacing the x with negative 3. So now I do some math. I'm going to have y equals, now 2/3 times negative 3. Think back to when we were multiplying, back to 5th grade when we were learning multiplying fractions. I could imagine that this is over 1. So 2 times negative 3 is negative 6. 3 times 1 is 3. So I have negative 6 over 3. Negative 6 divided by 3 is going to give me negative 2. Okay, so 2/3 times negative 3 is going to give us negative 2. Or another way that we could go about doing it is we could do some canceling. 2 times 1 is 1. I'm sorry, 2 times negative 1 is 1, and 1 times 1 is 1, so I end up with negative 2. Alright, so either way is fine as long as you're being careful with the math that you need to do. So y equals negative 2, and I'm going to bring down the plus 4. So negative 2 plus 4 will give me y equals 2. So when x equals negative 3, y is going to equal 2. Alright, next I'm going to substitute 0 in for x. Alright, so I substitute 0 in for x, and so now again I'm doing the math. So I have y equals, now 2/3 times 0, anything times 0 is going to give us 0. Bring down the plus 4, and we get y equals 4. So when x equals 0, y is going to equal 4. Next value to substitute in, we're going to substitute in 3. Go ahead and we're going to do the math again. Y equals 2/3 times 3 plus 4. 2/3 times 3. Well, this 3 and that 3 will cancel, so we're just left with 2. Bring down the plus 4, and so we get y equals 6. So when x equals 3, y is going to equal 6. And now at this point we should start to see a pattern emerging in the table, but even with that pattern we still need to make sure that we're showing all the work for each ordered pair in the table. And so last but not least, I'm going to substitute 6 in for x. And now I do my math. Y equals 2/3 times 6 plus 4. Well, 3 goes into 3 once. 3 goes into 6 twice. So 2 times 2 is going to give me 4. Bring down the plus 4. And we end up with y equals 8. So there is our table. Our x values are negative 3, 0, 3, and 6. Our y values are 2, 4, 6, and 8. We should see if we see a pattern in one row, we should see a pattern in the other row as well. So now that we have our 4 ordered pairs, we need to plot those 4 ordered pairs on a coordinate grid and graph the line for those points. Our first ordered pair that we need to plot is negative 3, 2. So I'm going to go to the left 3 and then up 2. My first point goes right here. Next point I'm going to plot is 0, 4. I don't go left or right at all, but I do go up 4 units from the origin. Second point goes there. Third order pair, 3, 6. So I go right 3 and up 6. And my final order pair is 6, 8. So I go to the right 6 and up 8. To put my point right there. So now that I have those points on my graph, I need to go ahead and draw the line connecting them. And not too bad. Alright, so that line and that table both represent the equation y equals 2/3 x plus 4. They're different ways of representing the equation, but both the table and the graph represent that equation. Now I want to take just another moment to talk about the x values that I chose in this table. These values right here. If I had not chosen multiples of 3 for my x values, I still could have gotten this same exact graph. Okay, I still would have gotten this graph if I hadn't chosen multiples of 3 for my x value. The only difference would have been is that these y values would have been decimals or fractions, and they would have been much more difficult to actually graph on the coordinate grid. So choosing multiples of 3, because my denominator is 3, made finding my y values easier. If you forget to use multiples of 3 here, and you end up with decimals or fractions here, that could still work. It's just going to be a little bit more work and a little bit trickier. So let's take a look at more of a real life scenario with our final example. So for our final example, we have a large cheese pizza costs $10. Each topping you order costs an additional $2. This can be represented by the equation y equals 10 plus 2x, where x represents the number of toppings and y is the total cost. So what we're going to do here is we're going to do the same thing as we've done for the first two examples. We're going to create a table, and we're going to then graph the table. Now, the first issue that we have is when we make our table, we're not going to use negative values here. Okay, you can't have negative toppings on a pizza. Even if you order a pizza with just sauce and no cheese, that doesn't mean there's negative toppings. Okay, you can't order negative toppings. So we're going to use positive values for x. Even if you don't get any toppings, that's still a cheese pizza. Okay, so we're going to use positive values for x. We can also use the number 0 because it is possible to order pizza with 0 toppings, but you cannot order pizza with negative toppings. So let's go ahead and make our table. So I have my table, and for my toppings, I'm just going to choose 0, 1, 2, and 3. Okay, I could keep going with the table, but really if you're getting more than 6 toppings on a pizza, you're just getting too many toppings on a pizza. So now what we need to do is we need to figure out the cost. So I rewrote my equation below the table, and again what I'm going to do is I'm going to substitute in my x values from the top row in for x. I'm going to solve for y, and then write those values in the bottom. So first I'm going to solve for if I order a pizza, a large pizza with no toppings on it, with 0 toppings. Well, from the information that we were given earlier, we know that it's going to be $10, but let's show the math. So we have y equals, we have 10 plus 2 times 0 is 0, so we have y equals 10. So a pizza with 0 toppings, a large pizza with 0 toppings is going to cost us $10. Now we want to figure out how much it is for a 1 topping pizza. So we substitute 1 in for x. We have y equals 10 plus 2 times 1 is 2. So a 1 topping pizza is going to cost us $12. Next we find out how much it would be for a 2 topping pizza. So we have y is equal to 2 times 2. Y is equal to 10 plus 2 times 2. So 2 times 2 is going to give us 4. So a large pizza with 2 toppings is going to cost us $14. Finally, we're going to substitute in 3 for 3 toppings on the pizza. So y is equal to 10 plus 2 times 3 is 6. So a large pizza with 3 toppings is going to cost us $16. Alright, so now what we need to do is we need to graph these values on a coordinate grid to see what our graph of our line will look like. So created my graph. I'm only using the first quadrant here because all my values are positive, and that's generally going to be the case whenever we're dealing with a real world scenario. We're not going to be dealing with a whole lot of negative numbers when it comes to real world scenarios. Now what I want to point out to you guys is the scale I'm using. For my x-axis, my scale is going up actually by a half each time. So I'm skipping a grid line, then have 1, skip another grid line, then 2, skip another grid line, then 3. So each grid line actually represents a half a unit. Okay? And I do that just to kind of spread my data out a little bit so that my values aren't all crunched up against the y-axis. For my cost, on the other hand, instead of going up by a half like I am with the x-axis, for the y-axis I'm actually going up by 2 units for each grid line. So I only wrote in the multiples of 4, but each grid line goes up by 2. So I have 2, 4, 6, 8, 10, 12. Okay? And keep on going up from there. So I wanted to point out that scale on my axes for you guys to see that. Okay? So my first order pair is going to be at 0, 10. So I'm not going up or down at all. Just placing a point right here at 0, 10. Okay? Next order pair I was at 1, 12. So I go to the right 1 unit, but that's 2 grid lines. Go to the right 2 grid lines, and then up to 12, which will be right there. Third order pair is at 2, 14. So I go right 2 units, but that's equal to 4 grid lines, and then up to 14. And then finally I go to the right 3 units, or 6 grid lines, and up to 16. Alright, so I've plotted my points. And now here's the kind of tricky thing about some real world situations. Up until this point we've been drawing lines, right? But for this problem we're actually not going to draw a line. And the reason for that is if you think about it, a line represents all the possible points, all the possible values in between the points that we have actually plotted. So if we were to draw a line here, that would say that we could get fractions or decimal parts of toppings. And while in this situation it might kind of break down a little bit because you can maybe order a topping on half the pizza or something like that. We're not gonna draw our line because you can't order a decimal or a fraction part of a topping in this scenario. Okay? So if we were to draw a line, that means that we're representing all the possible values that could be conceived, all the rational numbers, irrational numbers, all those types of things. But in this situation, it's just going to be the number of toppings. We can't order a fraction or a decimal of a part of a topping. Now, on the other hand, let's say we're talking about like water level of a lake or something like that. Well, certainly water level doesn't just drop by a foot or drop by an inch or things like that. It gradually goes down or gradually increases. So if it were that type of problem, that is a situation, a real life situation in which you would want to draw the line. And guys, it's just one of those things where you have to think about, all right, does this situation warrant me drawing a line, or am I just going to leave the points where they're at? All right, so guys, that about wraps up our lesson. A couple closing thoughts. I do want to tell you guys just to do the best you can when plotting points on MyHRW. I know that it can be very frustrating trying to do it with a trackpad on a Chromebook, and it does seem as though MyHRW can be very sensitive. So if you're getting a problem wrong that you believe to be right, message me and GoGuardian. Let me take a look at it to let you know, yes, you are doing that right. It's just being sensitive in MyHRW, or no, you're not doing that right. Here's what you should be doing instead. Okay, so just be as precise and be as careful as possible when you are plotting points in MyHRW. I also want to say one more time that if you have a graph that passes through the origin, that makes it a proportional relationship. All other graphs, all other lines, if they do not pass through the origin, they are not a proportional relationship. So the only way you can have a proportional relationship on a graph is if the line goes directly through the origin. All other lines, if they don't pass through the origin, they are not proportional. Okay? Write down any questions that you guys have so that we can discuss them in class tomorrow. And I hope you guys feel confident and able to graph linear relationships from an equation using a table.